Right, this is me going through fractional distillation exam questions. Just going through the first set real quick. Right, which statement about fractional distillation is correct about crude oil? Fractional distillation, remember, is HERCC at boiling point. Zeolite nat, cracking, zeolite catalyst. Each fraction contains a mixture. Yes. Brilliant. I mean, that's nonsense. You don't break covalent bonds, you break weakening intermolecular force and van der Waals. The fractional I mean, it's just not true, is it? So it's got to be B. Octane and isooctane. Isooctane, no, isooctane. Octane and isooctane are structural isomers with the molecular formula C8H18. We do more about structural isomers later. But they both have C8H18. The displayed formulas of octane and isooctane are shown in figure 1. Give the Iupac name for isooctane. So we've got to find the longest chain first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, there's the longest chain. So we're dealing with a pentane. We've got a pentane with 1, 2, 3 methyls. So that is trimethyl pentane. Now we've got to say where those methyls are. Well, this is going to be position 2, 3, 4, 2, 2, 4, 2, 2, 4, trimethyl pentane. Octane and isooctane can be separated in the laboratory. Name a laboratory technique that could be used to separate them. Well, this is a straight chain and this is a branched. So we know that the branched will have a lower boiling point. So they've got different boiling points. Oh, actually, look at that. They've got different boiling points. It tells me there. They've got different boiling points. So distillation would work. Fractional distillation would work, or distillation. So outline the idea. So if you heated these up together, maybe if you had a flask like that with octane and isooctane in, and you had a condenser, maybe with a thermometer in the top there, some sort of Liebig condenser or Liebig condenser, you heat them up, and the isooctane, so when it reached 99 degrees C, the isooctane would evaporate and condense, and the isooctane would boil off first. So what does the mark scheme say? The one with the low boiling point boils first and then condenses first. So the isooctane would boil and condense first, and then the octane would come off. Isooctane is added to petrol to increase its octane rating. Some high-performance engines require fuel with a higher octane rating. Okay. Write an equation for the complete combustion of isooctane. Use the molecular formula C8H18. So complete combustion. So that's going to be reacting with oxygen. You're going to make CO2 and H2O. There's 8 carbons, so there's going to be 8 CO2s. There's 18 hydrogens, so there's going to be 9 H2Os. Now you've got to go back to the other side and do the oxygens. 16 plus 9 is 25, so that's going to be 12.5 or 12.5. You can either write fraction or decimal, doesn't matter. Right, here are some boiling points of alkanes. They are different. So they've got longer alkanes, stronger van der Waals. Longer alkanes, stronger van der Waals. State of process used to separate an alkane from a mixture of these alkanes. Fractional distillation. You've got a range of different lengths there. So fractional distillation is better than just distillation. Both C3H8 and C4H10 can be liquefied and used as fuels for camping stoves. Which one will be able to be liquefied easily? So what they're suggesting is you've got these, they are both gases. So which one is going to be easiest to turn into a liquid? So we're after the one which has got the strongest van der Waals forces. So C4H10 will be most easy to liquefy because it is a larger molecule with stronger van der Waals forces. Therefore, it will have a higher boiling point. Right? Write an equation for the complete combustion of C4H10. C4H10 plus O2 makes 4 CO2, 5 H2O. 5 plus 8 is 13, therefore 6.5. 6.5 O2. Balance the following equation that shows how butane is used to make the compound called maleic acid. Okay, so let's have a little look here. Normally what I do with equations that require balancing is I put a little star next to them and come back because they tend to take more than a minute. Let's have a little look though. 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. All of the hydrogens from here will end up over here. The oxygens are in two places. I'm going to come back to it. I am, because that's going to be quite tricky to balance, I reckon. It's because they put numbers in front of there. I want to do it now, though. Actually, I'll just try and balance my oxygens. 1, 2, 3 oxygens. So what if I go 1, 2, 3, and then there's 4, and then maybe not. What if I balance my hydrogens? I know all my hydrogens here will end up over here. I'm going to come back to it. I'm going to do exactly what I said. I'm not amazingly quick at balancing equations, so exam technique, I knew I should have done it, is just stick to it. Come back to it later, throw some numbers at it later. It always takes more than a minute. I've just wasted time in my exam. Alright, ethane thiol is a compound with an unpleasant smell. It is added to gas to enable leaks from gas pipes to be more easily detected. Ethane thiol and ethanol molecules have similar shapes. Why does ethanol have a higher boiling point? Alright, so boiling points, you are dealing with either van der Waals, permanent dipole, or H-bonds. Right, this is ethanol. This is ethane thiol. Ethanol can form hydrogen bonds to neighbouring molecules. Ethane thiol can form permanent dipole to neighbouring molecules. Van der Waals, H-bonds, so this does H-bonds, this does PD, or Van der Waals. It's not the strongest dipole in the world, it is ever so slightly dipole. So it's hydrogen bonds versus dipole. Hydrogen bonds are the strongest weak intermolecular force, or hydrogen bonds are stronger than permanent dipole. The following compound is an isomer of one of the alkanes. Give the Iupac name. So, longest chain, 3, so we're dealing with a propane. It's got a methyl and a methyl, so it's dimethylpropane. Position number 2, but you don't have to put these numbers in because they're unnecessary. They don't give you any extra information. X has a boiling point of 9.5 degrees C. Explain why the boiling point of X is lower than its straight chain isomer. Because less surface contact with neighbouring molecules, therefore weaker van der Waals. Less surface contact. You can say it's like spherical, or it's more spherical. Less surface contact with neighbouring molecules. Look at my handwriting, it's amazing. Don't write like that in an exam. Less surface contact with neighbouring molecules, therefore weaker VDW. You can't write VDW in the exam. You have to write Van der Waals. You're my wonder wall. Right. Let's have a look. What question am I on? 4. The fractions obtained from petroleum contain saturated single bonds, hydrocarbons made of hydrogen and carbon only, that belong to the homologous series. There's 5 things from homologous series. Any homologous series can be represented by a general formula. State 2 other characteristics. Aha, I knew there was going to be to do with this. 5. So, what's the one? They change by CH2 each time. They've got similar physical properties. They've got similar chemical properties. Same functional group. Trend in physical properties. Yeah, trend in physical properties or similar chemical properties. I think that's it. Let's have a look at the mark scheme. Yeah, that's right. Alright, what process? Fractions, that's fractional distillation. What is saturated is single bonds only. Mark scheme says this. I don't like that. Saturated, single bonds. Having no double bonds. Well, you could have triple bonds. You might not have any double bonds, but you might have triple bonds. You'd still be unsaturated. Anyway, what I'm saying is saturated single, saturated single, saturated single, saturated single. Make that stick. Decane has the molecular formula. What is meant by the term molecular formula? Okay, so you've got to know this definition for what is meant by all of the terms, types of formula. The molecular formula is the number of atoms of each element. The number of atoms of each element in a molecule. The number of atoms of each element. Alright, just tells you there's 10 carbons and 22 hydrogens. Doesn't tell you anything about the structure. It just tells you the atoms of each element. Give the molecular formula of the alkane with 14 carbons, C14H30. Quite an easy paper, this, isn't it? Gas oil, mineral oil, blah, 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 and petrol are 4 of the 5 fractions obtained by the fractional distillation of crude oil within the temperature range 40 to 400. Identify the missing fraction. Ooh! Oh, I didn't expect that. Gas oil, diesel, kerosene, mineral oil, and petrol are 4 of the 5 fractions. Now, there's nothing that suggests, remember we just discussed this, didn't we, Luke Ambrosini, that you don't need to know the fractions. Well, I'll tell you what, this must be an old question. I need to clarify that. I'm going to phone up Dr. Halliday in a minute and find out, do we need to know it? There's nothing on the spec that says you do. I think it might be off an old specification. Apparently the missing fraction is naphtha. Naphtha. Now, you don't hear people saying, I need to put some naphtha in my car, or, you hear about petrol and diesel in cars. So naphtha is generally processed further to just make general chemicals for the chemical industry. It goes on to make other stuff. It's often cracked. State the order in which the 5 fractions are removed as a fractionating column is ascended. Yeah, this is old school. Old school. I'm sure of it. You don't need to know these fractions, but let's have a look anyway. Smallest is gasoline, then kerosene, then diesel. Oh, where's naphtha? Little people. Can't remember it now. From the, as it's ascended. So I'm just doing this as a challenge now to myself. Lubricating oil is going to be the longest. So lubricating oil or mineral oil. Then there's going to be, diesel's pretty long. I reckon diesel. Come on, Norton. Kerosene. I think naphtha's quite short, and then petrol. Anyway, that's the one I need to check out, isn't it? Because I know Ambrosini's probably at home now going, you told me, we didn't have to know that. I know he gets really ragey. That's it, that's the first one done. I'll get that uploaded. Alright everybody, so just recording this second video. You will definitely hear some of my 2-year-old daughter singing because she sat right next to me. She might go in a minute when she gets bored. So we're just going to go through this real quick. This is the second set of organic questions. Central heating fuel oil obtained by the fractional distillation of crude oil contains saturated hydrocarbons. Give the meaning of the term saturated. Saturated, single bonds only. Hydrocarbon, made of hydrogen and carbon only. No, only, no mark. You can't just say made of hydrogen and carbon. If the boiler for a central heating system is faulty, a poisonous gas may be produced. Oh, this is going to be a little bit too much, this, I think, with her singing. Yeah, can't do it. Yeah, nah. Alright, this is my second attempt after my first one was interrupted by my daughter coming in. So, central heating crude oil. Saturated, single bonds only. Saturated, single bonds only. Hydrocarbon, made of carbon and hydrogen atoms only. Carbon and hydrogen atoms only. No only, no mark. If a boiler for a central heating system is faulty, a poisonous gas may be produced. Poisonous gas, carbon monoxide. Write an equation for the reaction that forms a poisonous gas. So, and one other product only. Okay. C16H34, well I know it's going to make CO2, the other product must be, I know it's going to make CO, the other product must be H2O. It's incomplete combustion we're after. 16 carbons, that's going to be 16 carbon monoxides. 34 hydrogens, half of 34, 17 H2Os. How many oxygens? That's 17 plus 16. Oh, come on, Norton, where's your brain box? 16 and a half? 16.5, or you can write 16 and a half. Alright. Just have a little drink there. Explain why the sulphur compounds found in crude oil should be removed from the fractions. If you don't remove the sulphur, they're going to burn and they're going to produce sulphur dioxide. And sulphur dioxide reacts with H2O to make acid rain. I imagine they're the marks. Let's check the mark scheme. SO2 produced makes acid rain. What happens with sulfur dioxide? Sulfur dioxide goes into the clouds, reacts with H2O, and it literally adds to make H2SO3, which is called sulfurous acid, why am I pronouncing it like that? And then this is then oxidized in the rain to make H2SO4, which is sulfuric acid. It's very, very dilute though. People have this idea that acid rain, oh, it's acid rain, it's going to burn my face off. It doesn't. It's really dilute acid. It's dilute, strong acid. So it rains and rains and rains. It's a cumulative effect. If it rains acid rain an awful lot, it will get into rivers and ecosystems, and it'll start to, and trees will absorb it through their roots. So trees will die. You typically see the effect of acid rain quite quickly in plant life, also in aquatic life where it's built up. But yeah, you don't go out and you go, oh, it's acid rain today, we need to cover ourselves in alkali. It's like nothing like that. And it's less of a problem than it was because of stuff that you've read about. Sulfur dioxide is often removed from flue gases, from chimney, flue just means chimney, from flue gases by reacting it with things like calcium oxide, acid, base, neutralization reaction. Anyway, a hydrocarbon C16H34 alkane can be cracked to form this, and this. Write an equation to show this cracking reaction. I quite enjoy these. H34, so it's going to be cracked. There's no other reactant. Zeolite. You don't need to write zeolite. C8H18, it makes C8H18. Ethene, which is C2H4. Propene, which is C3H6. C2H4, C3H6. Let's add them up. 8, 9, 10, 11, 12, 13. But we've got 16 over here. So we've got to make this balanced. So how could you do that? Well, you could have 2 of these. That makes 6 carbon, 6, 7, 8. 8 plus 8 is 16. That works. Would it work if you did 3 of these? Yeah, it would. You could have 1 of these, 3 of these, and 1 of these. 6, 7, 8, 9. No, it wouldn't. No, it wouldn't. Sorry. 6, 7, 8, 9. No, it wouldn't work. This works. Right, cool. Of course it wouldn't work. You needed 3 more, didn't you? Silly man. Right, suggest one important substance manufactured on a large scale from propene, polypropene? Yeah, okay. There are some other things that are given as options in the mark scheme, but we haven't done about the reactions of alkenes yet, so the only one that we know from GCSE is alkenes can make polymers. Do you know the displayed formula? Displayed means like a peacock showing all of its feathers, so you need to show all the bonds of the functional group isomer of propene. We ain't done that yet, have we? Sorry about that. Well, the functional group isomer, by the way, if this is propene, 1, 2, 3, 4, 5, 6, you need to draw something that is C3H6, but has got a different functional group. Alkenes have got functional group isomers of cycloalkanes. We do a lesson on this, so don't worry. That's a good tune. That's called my isomer tune. That's a cycloalkane. It's pretty cool. 3 carbons in a little loop. I might actually have enough carbons for this. Got a model kit at home. What a geek. Let's have a look. That's a cyclopropene. It's called cyclopropene, C3H6. It is a functional group isomer of this because it's got the same formula, molecular formula, C3H6, but a different functional group. Its functional group is a cycloalkane. That is an alkene. Didn't intend to spend any time on that, but that's that. There are many structural isomers with this molecular formula. Draw the structure of 2,2,3 trimethylpentane. Read them backwards. All right, start here. Pentane, 1, 2, 3, 4, 5. I've done that bit. Trimethyl in positions 2, 2, 3. So I've got 3 methyl groups to put in. If I let this is 1, this is 2. So I'm going to go 2. There's a methyl there. It's a structure, so it doesn't ask for displayed, but I'm going to do it displayed because it's the most clear, and 3,3, so I'm going to need a CH3 here and a CH3 here. I am not going to draw all of the hydrogens, you would have to. Yeah, you could have written them as CH3s because it didn't ask for skeletal. But if you did do that, you'd best make sure that the bond goes to the carbon. If you do something like this, where a bond goes to a hydrogen, no marks. Alright? Carbon forms 4 bonds, hydrogen forms 1 bond. Bear that in mind, I'm a real stickler for it. Right, next, the compound C8H18 reacts with chlorine to give several haloalkanes. Haloalkanes? Give the Iupac name of the following haloalkane. Well, I don't know if you've done these yet, so we'll have a look. Anyway, longest carbon chain, 1, 2, 3, 4, 5, 6. So you're dealing with a hexane. I'll do that bit first. Then I've got a methyl, a chloro, and a chloro. So I've got a dimethyl, and I've got a dichloro. Dichloro comes before the dimethyl because it's alphabetical. Dichloro, dimethyl. Then you've got to tell me where the 2 chloros are. 1, 2, 3, 4. 2, 4 dichloro. 1, 2, 3, 4. 2 chloro, 4 dimethyl. I'll just check from the other way. 1, 2, 3. Otherwise it's 3, 5. Anyway, 2, 4 dichloro, 2, 4 dimethyl hexane. Some oil-fired heaters use paraffin as fuel. Give the name of the substance from which paraffin is obtained. Crude oil. You can say petroleum, but crude oil. Process through which you get paraffin is fractional distillation. OBS. The combustion of dodecane is 12, produces several products. Write an equation for the incomplete combustion of dodecane to form gaseous products only. Incomplete combustion, you start off with dodecane, C12H26. You're going to react it with oxygen, leave a little gap there. You're going to make... right, gaseous products only means you're not allowed to say carbon because carbon is soot. So I might do some carbon monoxide and some water. And balance that, or you could do a mixture of carbon monoxide and water and carbon dioxide and water if you want to make your life more complicated. I don't know why you'd want to do that. I think that you might as well just do this. 12 of them, 26, that's 13 H2s, and then go back to balance this. 12 and a half, I think, 12.5. Oxides of nitrogen, so this is the bit on those Elliott Rinsel videos. Oxides of nitrogen are produced during paraffin. Explain how these oxides of nitrogen are formed. Nitrogen is not found in the fuel. The nitrogen, you've got nitrogen from the air, reacts with oxygen from the air in the heat of the combustion or the heat of the engine or whatever it might be, or the heat of the paraffin lamp. The point is from air, not from the fuel. The nitrogen and the oxygen from air react at high temperatures. Next, don't complicate this. Write an equation so nitrogen monoxide in the air is converted into nitrogen dioxide. Nitrogen monoxide, that wasn't me just being... so, write an equation. It's like, do you know the formula for... What's the formula for nitrogen monoxide? NO. No need to be rude. Write an equation so how nitrogen monoxide is converted to nitrogen dioxide. NO2. That's easy, isn't it? Or you can multiply all of that if you don't like halves. 2NO plus O2 makes 2NO2. You're allowed multiples. A little drink. Nitric acid contributes to acidity in rainwater. Deduce, work out, an equation to show how nitrogen dioxide reacts with oxygen and water to form nitric acid. Okay. Nitric acid is HNO3. How does nitrogen dioxide react with oxygen and water, H2O and O2, to make HNO3? Let's have a little look. Well, how's about, I've got 2 hydrogens there, so if I do that, and then I've got 2 nitrogens, so if I do that, and now I've got 6 oxygens, 1, 2, 3, 4, 5, 6, 7. Half of that. That works. Or you could multiply all of those by 2. Anyway, I deduced it, and you saw me deducing it. I honestly haven't tried that question before. You could have 4, 2, and 1. In other words, don't go scratching your head going, I wonder how that works. You're told what to put in, you just got to balance it. Dodecane can be cracked, done that question. Explain why the melting point of dodecane is higher than the melting point of the straight chain alkane produced by cracking dodecane. Oh right, because the straight chain alkane that's produced by cracking will be shorter. If it's shorter, it's got weaker van der Waals forces between the molecules. If it's got weaker van der Waals forces between the molecules, oh sorry, I'm doing it the wrong way around, aren't I? Why is dodecane higher? Okay, do it the other way around. I was talking about why is the other one shorter. It doesn't really make sense to do that. Dodecane is longer, so it's got stronger van der Waals, so it takes more energy to break apart. Next, give the Iupac name for the following compound. Longest carbon chain, 1, 2, 3, 4, 5, 6. Hexane. Love this one. I've seen this one before. That's a hexane chain with 1, 2, 3, 4, 5, 6 methyls. Well, 1 methyl is methyl, 2 methyls is dimethyl, then you got trimethyl. Then you got tetramethyl, then you got pentamethyl. This is hexamethyl hexane. It's a hexamethyl hexane, but you got to tell me where these 6 methyls are. One, they're on position 2, 2, 3, 3, 4, 4. Yeah, 2, 2, 3, 3, 4, 4, comma, 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 chameleon. Right, type of structural isomerism. We haven't done that yet, but it's called chain isomerism. Right, earthquake. Dodecane can be converted into halodecanes. Don't need to know that yet. Okay, do that later. Well done if you're trying to answer that, but you don't need to. Right, the correct systematic name for this one is... Somebody pinged me there on my computer. Who's that? Who's that? Okay, easy peasy. Right. The correct systematic name for... So you look for the length of the carbon chain. 1, 2, 3, 4, 5... Well, I'm going to draw this out again. I hate these representations. They're really annoying. That's weird. That should be a 3 there, surely. That should be a 3 there. You can't have a CH on its own. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's going to be a 6 there. I think I'm dealing with a hex. A hexene. So I've got CH3 twice, so that's CH3, both joined to this carbon, so there's a carbon. There's CH3 twice, joined to this carbon with a hydrogen on it. Then I've got a carbon with a double bond C, with a CH2, CH3, CH2, CH3, and a CH3 there. And this little thing dangling off must be a CH3. Anyway, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's 6 carbons long, so it's a hex. So it's either C or D. 2, 3, 4 trimethyl. Let's have a look. So I'm going to circle the hex. Right. Methyl, methyl, methyl. Position 1, 2, 3, and 4. It's 2, 3, and 4. Trimethyl hexathreene. The methyls are in position. There's 1, there's 2, there's 3, and there's 4. It's C. The answer is C. Not easy, that one, is it? No. Ping, ping. Everybody's pinging. Why are they pinging me? Because they're finishing the work. Excellent. Which statement about ethene is correct? Right, ethene. That. you don't necessarily know the rest, do you? But that is definitely true. It does burn in oxygen to produce carbon dioxide and water. Petrol contains saturated single, hydrocarbons, hydrogen and carbon only. Cool. Saturated single bonds only, hydrocarbon, hydrogen carbon only. Name the homologous series. Name the homologous series alkanes. What an easy question that was. Outline the essential features of the fractional distillation of crude oil. Right, this is my GCSE. HERCCABBT. You heat the stuff. It evaporates. The alkanes evaporate. They rise up the column. They cool as they rise, and they condense at their boiling point. And then I would probably write different alkanes have different boiling points. Shorter have a lower boiling point, longer have a higher boiling point. And secondly, I would also mention that the column is hot at the bottom. Yes, I have just written hot bottom. Okay, so now C8H18 is obtained by the catalytic cracking of suitable heavy fractions. What is meant by the term cracking? Cracking is, what would I say? It's the thermal decomposition of longer alkanes to make shorter alkanes and alkenes. Let's see what it says in here. What question are we dealing with? Cracking. Large molecules are broken into smaller molecules. Yeah, it's not as good as mine. Cracking, thermal decomposition of long alkanes to produce smaller alkanes and alkenes. Alright. Name the catalyst. Zeolite. Explain why oil companies need to crack suitable heavy fractions. There's not enough demand for the larger molecules. And there is a high demand and not enough supply for the smaller molecules, so they crack the longer molecules to make them smaller in order to meet demand. Write an equation for the incomplete combustion of C8H18 to form carbon monoxide and water only. C8H18 forming carbon monoxide and water only. Right, C8, 8 of them, 18, that means 9 of them. 8 plus 9 is 17, so that is 8.5 oxygens. Done that. Boom. Catalytic converter is used to remove carbon monoxide from the exhaust gases. Identify a catalyst using a catalytic converter. Oh, rhodium, I think. RH. Iridium, platinum, palladium. All of them. Write an equation so carbon monoxide is removed in a catalytic converter. Alright, carbon monoxide is reacted with nitrogen oxide, je pense. Which is French, I think. Co plus no. Co-no. Right, and you make nitrogen, I seem to remember, and you also make CO2. Which is better for you, because it doesn't kill you, but it does lead to global warming, so at least it doesn't kill you directly. Balancy. 2 of them. Is that it? Yeah, that's it. That's a piece of cake, though. Anything else? State why the water produced in the exhaust gases may contribute to global warming. Why the water produced? Water is a greenhouse gas. It absorbs infrared radiation. See what the Mark scheme says. It's a greenhouse gas. It absorbs infrared radiation. All right, but notice what I did there. Exam technique. I kept thinking, yeah, I've done something. Tempted to move on. You go, hang on, I'll just check. No, I've done that. No, I've done that. No, I've done that. Each of them's worth 1 mark. This is a long homework. This. When some petrol was accidentally contaminated in 2007, the sensors in effective cars caused a decrease in the supply of petrol to the engine. Suggest the effect that the contaminated fuel would have on the performance of cars. Well, I imagine it's going to reduce the performance of cars if you've got less petrol going into the engine. So reduced performance. That does say that. Or reduced power, maybe. State how the oil company might have recognised the problem before the petrol was sold. Gosh. What are they on about there? Check it? Test it? Something like that? Bit of a random question. What's it say? Test it. Test it before you sell it. Yeah. Okay. I don't actually know what bit of the spec that refers to. They sold some dodgy petrol. What might this have done? Cars wouldn't have worked as well. What should they have done? Not sold it, like checked it first. Alright. The molecular formula C8H18, God, they love C8H18, represents several structural isomers. What is meant by the term structural isomers? We've not done this yet, but basically it means same molecular formula, as in same molecular formula, C8H18, but H18, but with a different structure. That's all it means. Name the following. Chain 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think the longest chain is 5, so I'm going to circle a chain of 5. Pentane, you're seeing how I work now, yeah? 1, 2, there's 3 methyls on that pentane, so it's going to be trimethyl pentane, position 2, 2, 2, 4, 2, 2, 4, trimethyl pentane. Watch out for this. Some people do this. Trimethyl. They spell it wrong. Do you know what happens if you spell it wrong? You get no marks. Methyl. 2, 2, 4, try. Oh, got it right. Yay. Cool. Next. But1-ene burns in a limited supply of air. Butene, anyway. Butene. C4H8. But1-ene, by the way. There's but. And the ene means the double bonds in position number 1, not position number 2 and position number 3. Although position number 3 is position number 1. Whatever. But1-ene is this. C4H8. C4H8. So, a solid. Aha. The solid must be carbon solid. Carbon solid and water. H2O. You can't catch me out. 4 carbons. 4 of them. So I got distracted by my thingy again. 4 oxygens, that's 2 O2s. See how I got on there. 2 O2s, 4 carbons, 4 H2Os. I am smashing these questions in. 1 hazard with the solid product in part B. Alright, soot. It's bad for your breathing, so it makes breathing problems. Bad if you got asthma, damages your lungs, all that stuff. Alright, don't breathe in soot. Okay, 1 mole of compound Y. Where's compound Y? What's that one about? Don't know. Oh, I've got to read the rest of the question. That's not good exam technique, is it? To see compound Y and then panic. 1 mole of compound Y is cracked. To produce 2 moles of ethene, C2H4, 1 mole of but1-ene, which is C4H8, and 1 mole of octane, C8H18. Alright, so you got C2H4, C4H8, and C8H18 only. Add them together. 4, 5, 6, 14, C14. Hang on. It's 6. 2 moles of ethene. C16. H, and it'll be an alkane, 1 in 34. Adds up. Just adds together, doesn't it? Other than cracking, give a common use of Y. C16. Summit long, it's too long for petrol. So, I don't know, diesel. But it's a bit too short for diesel. Kerosene. Alright, looking at the mark scheme, you're allowed anything as long as it's not petrol or something short. And it's not super long like bitumen. So you're expected to know one of those middle fractions. Sorry, Luke. Sounds like you're expected to know it. In cars fitted with catalytic converters, unburned octane reacts with nitrogen monoxide to form carbon dioxide, water, and nitrogen only. Okay, let's go with this. Unburned octane, C8H18, again, octane, reacts with nitrogen monoxide, okay, NO, to form CO2, H2O, and N2. Deduce a balanced equation for this. Oh, you're kidding me. So what I would do first, 8 carbons, that makes 8 carbon dioxide, 18 hydrogens, well they're all going to end up here, so 9 of them. So you know they're fixed. Next thing to do then is to do the oxygens, because all the oxygens come from the nitrogen monoxide. So there's 16 plus 9, that's 25. So you'll need 25 nitrogen monoxides, and then you'll have 12 and a half of them. Identify catalyst using a catalytic rhodium, iridium, platinum, palladium. Wow, I set you a lot of work, didn't I? I've been doing this 26 minutes and I'm fast. Hexane is a member of the homologous series of alkanes named for crude oil. Name the process used to fractional distillation. C6H14 are structural isomers. How many structural isomers? Ignore that question. It's a good question, but we're not doing it now. State one type of structural isomerism. Sorry, everybody, we're not doing that now. One molecule of alkane X can be cracked to form one molecule of hexane and two of propene. Alkane X, deduce X. One molecule of hexane, C6H14. I'm panicking because I want me dinner. And two molecules of propene, C3H6. So C6H14 plus two molecules of C3H6. Add up your carbons, add up your hydrogens, stick it all over to this side, and you'll end up with C12H26. 6, 7, 8, 9, 10, 11, 12. C12H26. Nearly there, nearly there. State the type of cracking that produces a high percentage of alkenes. We learnt that today, didn't we? Thermal is alkenes. Catalytic is aromatics. Conditions. Come on, I said I was going to try and remember this. 1000 degrees C, 70 atmospheres. Is it? I'm sure that's what I learned before. Cool. It says in here anything higher than 10 atmospheres. Explain the main economic reason why alkanes are cracked. Because you can make products with an increased demand. There's low demand for the long alkanes and you're trying to make shorter ones, which are in higher demand. Next, hexane can react with chlorine under certain conditions. Shown in the following equation. Both the products are hazardous. The organic product will be labelled as flammable. That's that one, the organic product. What's the most suitable hazard? HCl, hydrochloric acid, corrosive? Corrosive, yeah. Calculate the percentage atom economy. Oh, I'm not bothered about that, to be honest. A different chlorinated compound is shown. Not bothered about that either. Because we've not done that yet. Done. See you later.